Okay, let's unpack this. We are diving deep into a single piece of hardware today. We're looking at the Thor Broadcast MaximusProX PTZ 20x zoom camera.
Mm-hmm.
And our mission for you is to show why the specs here go way beyond just, simple resolution,
Right.
which, for the record, is a solid 1080p from a 2.38 megapixel sensor.
Right.
But we want to get into the connectivity and control.
It's really the classic lesson in operational complexity over pure pixel count.
Exactly.
This camera, it's not built for your average video call. It's for really demanding applications. Think telemedicine, high-level conferencing, maybe large-scale education, or even church live streaming.
So for you, the listener, the immediate insight is that having simultaneous outputs just completely changes how you design a complex workflow.
It really does.
But wait a second. Processing 4 simultaneous video feeds. You've got SDI, HDMI, USB, and IP that usually needs a pretty beefy external box,
Yeah.
right? How is one camera managing all that?
That's the magic of what they call simultaneous multi-interface video output. It's designed to basically eliminate that external hardware. And what's really fascinating here is the inclusion of 3G SDI right alongside consumer standards like HDMI.
Why is that so important?
Well, SDI is a major professional standard. It uses rugged coax cable for really stable long-distance signals. HDMI just can't guarantee that over, say, 50 feet.
So you'd use the 3G SDI for your secure internal broadcast monitor or something like that?
Precisely. And then you use the IP streaming to hit the web.
And that IP stream supports RTMP and RTSP.
Yep, so you can feed platforms like YouTube and Facebook or software like OBS directly from the camera.
And it handles all that load by using H.264 and H.265 super decoding.
Which dramatically cuts down the bandwidth you need to push all those signals out at once.
Okay, that leads us nicely to the mechanics. Once you have the signal, you need absolute control over where the lens is pointing. We're talking about an ultra-quiet hardware structure. It covers a 178-degree pan and an Attica 30 to plus 90-degree tilt.
But the real insight there is the precision. The stepper motor drive has an accuracy down to 0.01 degrees.
0.01, what does that actually look like?
To give you a tangible idea, imagine you're aiming a camera from one end of a football field.
Okay.
And you adjust its view by the width of a single piece of thread on the goalpost at the other end. That's the level of control we're talking about.
Wow. And that's essential for tracking, say, a surgeon's instrument or isolating one speaker in a huge boardroom.
You got it.
And that kind of surgical precision needs robust integration. This camera has to speak the industry's language.
Right. It works instantly with established protocols. Think VSCA, Pelco PD, and OnVFDF.
So you can control it through almost anything. RS-485, RS-232, or LAN with VSCA over IP.
Supporting all those means you're not locked into one vendor's control system. It's true flexibility.
And it supports power over Ethernet, PoE, which must make installation so much simpler.
Oh, it's a huge deal. It cuts down cable clutter tremendously. It even has a built-in USB port for, like, one-click local recording.
So let's quickly tie the image specs back to those applications. You have that 20x optical zoom plus a 12x digital zoom.
And a field of view from a very tight 2.9 degrees up to a wide 65 degrees.
When you're zoomed in that tight, on a surgical demo, for instance, image noise becomes a massive problem, doesn't it?
Exactly. That's why the built-in 2D, 3D noise reduction isn't just a nice-to-have, it's a necessity.
And what about mounting it?
The installation design is really flexible. It supports mirror and flip functions, so if you need to ceiling mount it, the video just flips instantly. Wall, tripod, ceiling, you'll get a reliable broadcast-grade output, like 1080p 60.
So what does this all really mean for you? This camera is built to bridge every professional broadcast standard.
It delivers high efficiency and flexibility, handling high-quality 3G SDI and low-bandwidth H.265 streams at the same time.
So the new baseline for professional remote applications isn't just about 4K or 8K resolution.
Not at all. It's now defined by that combination of efficient streaming and that 0.01-degree mechanical reliability.
Which brings us to a final provocative thought for you to consider. Given that the specs really focus on network reliability, things like high-efficiency lost packet recover and wake on LAN support, how much does the reliability of the protocol now outweigh pure resolution in critical applications, like remote surgical observation?
That's a great question.
Something to mull over until our next deep dive.